In this video, we'll discuss using alternative value retrieval methods for the PyPoint data reference in order to get things like summary statistics or totalizations on a Pi tag and display them in AF attributes. So for example, if I jump back to my completed database, you can see here that for each piece of equipment, I have this energy usage for the last hour, and what this is doing is it's going in and it's doing a total for the last hour worth of data on the power attribute, and that's going to give me the energy usage for the last hour for that piece of equipment. And this is useful because then we can use the unit cost of our energy that we're getting from the power company and then calculate how much it's costing us to run each piece of equipment over the last hour. Another way this can be useful is to calculate averages of data over a certain block of time in order to get a smoothed view of the data. So let's run through that example together in our HVAC database and see how that works. So returning to my zone 1 element, and we're going to look at the indoor temperature. And as you can see, it has a pretty bumpy trend here, and say maybe we just wanted to see a more smoothed view of that data. And we decide that hourly averages would be sufficient. Well, what I can do is first I'm going to build a child attribute for the indoor temperature. Now, of course, I could have built a new separate attribute at the same level and called it 1 hour indoor temperature average, but from an organizational standpoint, it's nice to just have each of our summary statistics grouped underneath the tag that we're doing the statistics on. So again, I've created this attribute underneath my indoor temperature, and now I can just call it, say, 1 hour average. And we'll go over here. And again, this is going to be degrees Fahrenheit that we're using for our temperatures. And then I'll go in here and do a PyPoint. Now, again, I could go find the indoor temperature tag for zone 1 using our tag search and fill it in. But an easier way to do it is to select this attribute radio button, and then I can just borrow that tag from the indoor temperature. It's also nice because then this new child attribute is linked to the parent and will do the average on whatever tag the parent is using. Also, since it's looking at the parent attribute, it's going to go ahead and fill in the source units correctly for us. So now we're down to this value retrieval method area, which is what we're interested in. And I said I want to do 1 hour averages, so I'll start with the relative time. We'll use star minus 1h. And in the by time range, I'll select average. And then to make sure that I'm always using that 1 hour time range, I'll go down here and select time range override. Now you also may have noticed as I went down that list, there was another selection for time range. And these will essentially do the same thing. They'll calculate averages over the time range that you specify here by default. The main difference is that if we use the time range method and we're using a client tool like ProcessBook where a time range can be specified for the display, then this average will be calculated for the time range given by the display. Whereas if I use time range override, the calculation will always be done using the time range defined within the attribute. So I'm going to go ahead and use time range override with 1 hour here. And just to show you the difference between those two selections, I've built a process book for my completed database. Yes, we'll go ahead and check in our work. And as you can see here, if I go to zone, I've built one of these averages using the time range override method and a 1 hour offset. And this other one, I've gone through and again, I've used a 1 hour, star minus 1 hour relative time, but this time I'm using the time range method. So let's see how that affects my process book display that I've built for this indoor temperature. Now here you can see the time range for my trend is 60 minutes, and the values for the two attributes are exactly the same. The top value is using the attribute that uses time range override, and the bottom one is using just time range. But if I start zooming out and making the time range of my trend larger, let's say we go out to 16 hours where we have this step change in our data, we'll see once these averages update that now my time range override is still showing the same value, but my average that's doing the time range of the trend is now 74.5 approximately, which is about halfway between these two major chunks of data. So this first one is essentially using the last hour of data, so maybe something like approximately this part of the data, whereas the second one is going to be using all 16 hours, so it's going to take all of the data in this trend to calculate its average. But in either case, you can see that when we trend the hourly data, we get this nice smoothed view of our original temperature data. So the green is the temperature data, and then this blue line is the 1 hour averages, so we get a nice smooth view of our data. So obviously, as you saw in these settings dialogs, there's a lot more different selections for the by time and by time range parameters, and even for the way you weight averages and such. So I'd encourage you to look at the Pi System Explorer user guide if you have further questions about any of the other values that you can select for these parameters.